Okay, today we're going to be going over recursive formulas. This notes is going to be broken up into two different sections. We're going to be doing the first page on this video and then the back side of this page on the next video. So let's go over some review. It says, write the explicit formulas for each sequence below. So the first thing I want to do is I want to try to figure out, okay, what is happening with these sequences? It looks like this time I am adding 6, adding 6, adding 6. Let me just remind you that, so I know what my formula is doing. Let me remind you that the explicit formula for an arithmetic sequence looks like this. We're going to start off with a sub n is equal to, remember that you always start off with your first term, and then we are going to be adding, since we're adding 6 each time, we're going to be adding the common difference, so that's a d, and then you're going to be multiplying it by n minus 1. So that's the formula for the explicit formula for the arithmetic sequence. Now that I have that, I'm just going to start substituting my values. I know to get the nth term, I need the first term, which is 11. And I'm going to add to that, my common difference in this case is 6. And then write n minus 1. And that is the explicit formula for the arithmetic sequence. All right, let's go ahead and do letter B. For letter B, first I need to recognize the pattern. It looks like I'm multiplying by 3 each time, so let me jot that down. I am multiplying by 3, multiplying by 3, multiplying by 3. Now that I know I'm multiplying by 3, I'm going to go ahead and use the formula for a geometric sequence. And we said the explicit formula is going to be a sub n is equal to, you're still going to start off the same way. You're going to start off with your first term. But this time, you don't have a common difference, right? We have a common ratio. Because we're multiplying, we're going to multiply by that common ratio, which is going to be r. And I still have the n minus 1, but the n minus 1 in this case is going to be on the exponent. All right, again, that's the general form, but because I have numbers, I'm going to go ahead and substitute them in. So I'm going to write a sub n is equal to, my first term is 6, to the r to the, whoops, not the r, because I know my common ratio. My common ratio in this case is 3 to the n minus 1. All right, so there's the formulas for the explicit forms of each one. And let's go ahead and start seeing where we're going to be going today. There is another type of equation you can use to represent a sequence. A recursive formula is one where each term in the sequence depends on a term that came before it. Okay, so here's a sequence, right? And I'm just looking at my sequence right now, and I notice I have a first term, second term, third term. Then I'm going to go dot, dot, dot. Then I got these guys. It says the a sub n minus 1, the a sub n, and a sub n plus 1. So let's just remember what these notations means. When I say a sub 1, what I'm really trying to say is this is my first term. When I say a sub 2, what I'm really saying is this is my second term. When I say a sub 3, really what I mean is this is my third term. And those are pretty okay. Now the next ones are going to be kind of weird. So let me skip the a sub n minus 1 for right now. Let me go straight to the a sub n. You've seen that before. The a sub n just means that this is your nth term. Why are we using the nth term? Well, because, sometimes I want like my 46th term, or I want my 37th term. So I want an nth term. I want to be able to plug my number right in. Now, if this is my nth term, then this is one term before that, because it's like n minus 1, right? Imagine n on number line. N minus 1 means you're taking back a step. So when I say the n minus 1th term, what I really mean is the previous term. And I know that sounds kind of weird, but just bear with it for a while. So if the nth term is here, then the n minus 1 term must be the one before it, or the previous one. By that same token, if this is my nth term, then when I'm talking about n plus 1, then that means this should be the next term. But the one that we really want to focus on today is going to be this one. When I say a sub n minus 1, really what I'm trying to say is I want the previous term. And that's going to make more sense once we start calculating some of these values, okay? But the n minus 1 is the one we're really going to focus on today. All right, let's give you a little bit of a recap. Remember that for the explicit formula for an arithmetic sequence, it's a sub n is equal to the first term plus your common difference because you're adding times n minus 1. Guys, we've done this. We did it a little bit above. We just did it up here, okay? So that one's no surprise. Today, our focus, however, is going to be on the recursive formula for arithmetic sequences. So if you can do me a favor and with your highlighter, if you can go ahead and grab this, and just put a little thought bubble here, because this is the formula we're going to be using today. It's going to be called the recursive formula. This recursive formula says if you want your nth term, then what you need to do is you need to get the a sub n minus 1 term. Remember, a sub n minus 1, what that really means is you need to get your previous term, and then you need to add your common difference, okay? Again, right now it's not going to make sense, but I promise you the more we do these formulas, the more sense it's going to make, okay? All right. It says, write the first four terms given the following recursive formulas. Guys, this is going to be a lot of work, so leave a lot of space, all right? But I'm going to try to walk you through as much as you can. Remember, we want the first four terms. That means I want a sub 1, a sub 2, a sub 3, a sub 4. So let's talk about a sub 1. A sub 1, my first term. Do I know what my first term is? Well, yeah, of course I do. The first term is just 7. How did I know that? Well, they flat out told me. The first term is 7. Okay, so on the first term, not much to do. That one's just 7. I am done with the first one. So let me go ahead and write the first term was 7. For the second term, remember right now my n is 2. In order to get my second term, this thing says I need to get the a sub n minus 1. That is to say, I need to get my previous term. If I'm looking for the second term, then a sub n minus 1 must be the previous term. That means this must be a sub 1 because that's the term that came before the second term. It was my first term, and what I'm going to do with that is I'm going to add 4. Okay, what was my first term? My first term was 7, and I'm going to add 4, which means I get 11. You know what I just found out? I just found out that my second term is 11. So I get to go over here, and I get to write that the second term was 11. All right, let's figure out the third term. If I want to get my third term, let me split this up so that way we're not running into this stuff. If I want to get my third term, I'm going to use this formula. Remember, to get my third term, this says I need to get the previous term. Which one was the previous term? Well, the previous term was the second term. And I need to add 4 to that. What was my previous term? My previous term was 11. Because remember, a sub 2 was 11. And I'm going to add 4 to that. 11 plus 4, that gives me a 15. That means my third term must be 15. We're going to do this one more time. I want my fourth term. According to my formula, in order for me to get my fourth term, I need to get my previous term. Well, the previous term was the third term. So the third term was the previous term, and I'm going to add 4 to that. My third term was 15. And I'm going to add 4 to that, and I get 19. So this is my sequence right here. My sequence is 7, 11, 15, and 19. And if you notice what's happening each time in that sequence, I'm just adding 4. And that makes sense because this is telling you like, hey, in order to get your current term, you need to get the previous one and just add 4 to it. You're just going to keep adding 4 each time to the one before it, okay? Let's try it again. I'm going to go ahead and split this up using a red line just so We know we're working with letter B. Same thing, I want to find the first four terms, okay? I started noticing in class that some of you guys actually like just plugging in the previous term, and I'm going to do that for now, just because I think you guys are probably better at it. So I want the first four terms. All right, if I want the first four terms, I'm going to start off with the first term. I know that the first term is 2. How do I know that? Well, they flat out told me, like, there's no work there. You have to start somewhere, right? I know the first term is 2. Now that I know my first term is 2, now I can start working with my other terms. So if I want to get my second term, according to this formula, to get the second term, you need to get the term before that. Well, the term before that, we just said, was 2. So I'm going to take the 2, and what did they tell me to do with the previous term? They told me to subtract 5. So I'm going to take my 2, subtract 5, and I get -3. What I just found out was that my second term is -3. Let me go ahead and start writing these numbers. So the first number was 2. The second number was -3. Let's go ahead and find my third term. If I want to find my third term, according to the recursive formula, to find the third term, you need to get the previous term. What was the previous term? The previous term was -3. So to get my third term, I need to get the -3. That's my previous term. And what are they telling me to do with the previous term? They're telling me to subtract 5. So I'm going to subtract 5. I get -8. I just found out that my third term was -8. And then the last one, I'm running out of space. So let me go ahead and move this down here. And let me go ahead and do the fourth term down here. To get my fourth term, the formula says I need to take the previous term. The previous term was -8. I'm going to take that -8. What am I going to do with it? I'm going to subtract 5. And I get -13. What I just found out was that my fourth term is -13. And there is my sequence. Okay, I'm going to move a little bit faster. I think hopefully you're getting the hang of this. We're going to move fast. Let's see. On the first term, what is my first term? I know my first term is -3. On my second term, what did they tell me to do? Well, they told me to take the previous term and add 11. So I'm going to take the previous term, which is -3. I'm going to add 11. That gives me a +8. So I know my first term was -3. I know my second term is 8. Let's talk about the third term. How do I get my third term? Well, I need to take the previous term and add 11. So that means I need to take 8 and add 11. And that's going to give me a 19. And then for my fourth term, how do I get my fourth term? I need to take my previous term, which was 19, add 11. That gives me 30. I hope you understand, like, once you start getting the hang of this, like, the recursive formula makes it really easy. And notice, like, what's happening each time. I'm adding 11, adding 11, adding 11, which makes sense because it says take your previous term and just add 11. Okay? So the recursive formula is really easy once you get the hang of it and how to substitute the values. All right. On this one, we're going to go ahead and write the first four terms of the explicit formula, then write a recursive formula for the sequence. So what happens a lot in this case is we start getting the formulas confused. There's a big difference between an explicit formula, which doesn't have the previous term, and the recursive formula, which does have a previous term. Check this out. There is nothing about a previous term there. It just says a sub n equals 3n plus 6. So I want to get the first four terms. Students have been messing this up, and it's understandable, but it's really not that bad. I want to get my first term. So I'm going to look. Did they tell me my first term? No, it's not like the other formula because this one's explicit. So then students start getting a little lost here and saying, well, I don't know what to do. Well, I'm using this formula. And right now, you see that n? Well, my n is 1. So anywhere I see an n, I'm going to replace it with the number 1. I see an n right here. I'm going to replace that with the number 1, and I'm going to get 3 times 1 plus 6, which gives me 3 times 1 is, let me go ahead and just do it here to save myself a little bit of space. Hey, 3 times 1 is 6. I'm sorry, whoa. 3 times 1 is 3, and then plus 6 is 9. You know what I just found? I just found that my first term is 9. I want my second term. How do I find my second term? Well, right now my n is 2. So anywhere I see an n, I'm going to replace it with the number 2. So I get to write 3 times 2 plus 6. 3 times 2 is 6. 6 plus 6 is 12. So I know my second term. I'm going to go a little bit faster now. To get my third term, I'm just going to substitute 3. So it's going to be 3 times 3 plus 6. 3 times 3 is 9 plus 6 is 15. To get my fourth term, I'm going to go 3 times 4 plus 6, which is 12 plus 6, which gives me 18. All right, what did I just find out? I found out that my sequence is 9, 12, 15, 18. All right, I did the first part. I found the first 4 terms of the explicit formula using the explicit formula. Now I need to write a recursive formula for the sequence. Remember how our recursive formulas looks. There are 2 parts to it. The first part is you need to tell me what the first term is. The second part is to get the nth term, you need to take the previous term and do something. Okay, so let's figure out the pattern here. What am I doing each time? It looks like I'm adding 3 each time. This is plus 3, plus 3, plus 3. That means my common difference, my D, equals 3. All right, so let's start writing down the formula. Remember, the first part to writing down the formula is you need to tell me where we're starting. So my first term is 9. That is the first part of my recursive formula. The second part of my recursive formula is I need to write down how to get the current term from the previous term. So I'm going to write, in order to get your nth term, you need to take the previous term. And what are we doing each time with the previous term? Well, in this case, we're just adding 3. So I'm going to write, take the previous term and add 3. And that's it. You are done with that recursive formula. But remember, you need both parts. If you only have one part, it's not good enough. Okay, so first, tell me where you're starting. Second, tell me what you did with the previous term, and then that'll give you the recursive formula. All right, let's take a look again. Okay, so I think we are going to get the hang of this. I want the first 4 terms. Remember, in order to get your first term, we're going to say, did they tell me what the first term was? No, I got to figure it out. And that's okay because I know my n is 1. That means anywhere I see an n, I'm just going to replace it with the number that I have. So this is going to be negative 4 times parentheses 1 plus 15. All right, negative 4 times 1 is negative 4 plus 15 gives me a positive 11. To get my second term, I'm going to take negative 4, and this time I'm going to multiply it by 2 and add 15. Negative 4 times 2 is negative 8. Negative 8 plus 15 is 7. To get my third term, I'm going to take my n, and I'm going to replace it right here. So this is going to become negative 4 times 3 plus 15. Negative 4 times 3 is negative 12 plus 15 is a positive 3. Then the last one, to get my fourth term, that's going to be negative 4 times 4 plus 15. Negative 4 times 4 is negative 16 plus 15. I get a negative 1. So that means my sequence is 11, 7, 3, and negative 1. What's happening each time? Well, it looks like I'm subtracting 4. And some of you guys are going to say, no, you're not subtracting 4. You're adding negative 4. We know this is geometric. It really doesn't matter at this point as long as you know. I'm sorry. We know it's arithmetic. Sorry. We know it's arithmetic. As far as the recursive formula is concerned, you know it's arithmetic because it's adding negative 4. But you can write it as subtracting 4 and it's going to work just fine. It doesn't matter. Both ways will work. Okay. So I got my sequence down. I got the first 4 terms down. Now I need to write the formula. The formula, remember, there's 2 parts of it. The first part is we need to establish what the first term was. The first term, in this case, was an 11. Let's go ahead and highlight that in green. This is the first part of my formula. I'm starting at 11. The second part of my formula, I need to write a sub n. In order for you to get the nth term, you need to get the previous term. And what are we doing each time? Well, we're subtracting 4. So you can write it like that, Or you can say, oh, we're adding -4, and you can write plus parentheses -4. Both ways work. It doesn't matter. I'm going to write it this way just because it looks a little bit shorter. But you need both parts in order for this to work. Okay, the last one. I think we got this, so we're going to go a little bit quicker. I'm going to get my first term. They did not tell me the first term. I'm going to plug in the 1. I get -8 times 1 plus 2. -8 times 1 is -8 plus 2 gives me a -6. To get my second term, I'm just going to substitute the 2. -8 times 2 plus 2. That's -16 plus 2, which is -14. To get my third term, I'm just going to substitute the 3. -8 times 3 plus 2. That gives me a -24 plus 2 gives me a -22. And then for the last one, a sub 4 gives me a -8 times parentheses 4 plus 2, which gives me a -32 plus 2. That gives me a -30. Okay, so I have my sequence down. It looks like my sequence is -6, -14, -22, -30. What is my pattern in this case? Well, it looks like I am subtracting 8, or you can say that we're adding -8. In fact, this time I'm going to say it the other way. I'm going to say that we're adding -8 just so you see it a different way, okay? But just understand that you can write subtracting 8. Hey, by the way, that's no coincidence. The fact that I'm subtracting 8 each time is right here. The fact that I'm subtracting 4 each time is right here. And the fact that I'm adding 3 each time is right here. So there is a connection between your formula and the number that you're adding. It's the number right next to your variable n, okay? All right, how do I write the formula? Well, I need 2 parts to it. The first part is write down the first term. My first term in this case was a -6. That takes care of half my formula. Second part of the formula is I need to write what's happening to the previous term. So to get the nth term, you need to take the previous term. And in this case, we said subtracting 8 or adding -8. I'm going to write adding -8. Honestly, it doesn't matter. But I just want you to see it both ways. You could have absolutely wrote a sub n equals a sub n minus 1 minus 8 on the side. Okay, that takes care of the notes for the front side. On the next video, we're going to show you the notes for the second side.